So this question is from the 2002 exam. It's Form B, the international exam. I classify it as type 7. There's essentially 10 types of FRQ questions, and type 7 is the miscellaneous category where if it doesn't fit in the other 9 types, it goes in here. Now in Calculus AB, we only have 7 types, and then in BC you get type 8, 9, 10. So you don't have to worry about the last 3 until next year, unless you're a BC student. This one is a related rates problem, which means we're going to do our find when given statements. Ship A is traveling due west towards Lighthouse Rock. So in the diagram here we have ship A and it's traveling west, which would be that direction. So that means this distance here is an x, and then because it's changing we have a dx dt. At a speed of 15 kilometers per hour. So dx dt is 15. And because that value x is shrinking, dx dt is a negative value. The rate of change of x is decreasing. Ship B is traveling due north away from Lighthouse Rock at a speed of 10 kilometers per hour. So here ship B is a distance of y, and that variable is changing, so it has a rate of change, dy dt, and that value is 10. And because y is growing, it's going to be a positive 10. Okay. Let x be the distance between ship A and Lighthouse Rock at time t, and y be the distance between ship B and Lighthouse Rock at time t, provided on the diagram as shown in the figure above. Part A, find the distance in kilometers between ship A and ship B when x equals 4 and y equals 3. So when x equals 4 and y equals 3, what is the distance between them? Which I'm going to assign the variable z. And a lot of people recognize this as a Pythagorean triple and can quickly answer the value of 5. If you did not recognize it as a Pythagorean triple, you could use the Pythagorean theorem and calculate for that distance there. So we get 25 equals z squared, and therefore z is 25. There was not any calculus needed for that question. That was just basic geometry knowledge, and as such, it doesn't carry a lot of weight on the AP test, but you would get 1 point if you answered that correctly. Okay, so the distance in kilometers is 5. Sorry. You do need to probably show a little bit of work for that, because they're not a big fan on the test of just floating answers. So while I think this is sufficient for most people, I think the safer route would be to actually show the Pythagorean theorem. All right, moving on to part B. Find the rate of change in kilometers of the distance between the two ships. So part B is asking us to find dz dt. What is that? Find the rate of change of the distance between the ships. Okay? This is our find statement, and we oftentimes will set this up in a find when given scenario. Find this rate when, and in this case, when x equals 4, y equals 3, and z equals 5. That's when we're looking for this rate. And the rates that we are given is we're given that dx dt is negative 15 and dy dt is 10. So in this case we have 2 rates we're given, and we're being asked to find the third rate. So we need an equation that relates the variables x, y, and z, and fortunately for us we've already found that equation, x squared plus y squared equals z squared. That wonderful Pythagorean theorem. When we differentiate this expression with respect to time, we get 2x dx dt plus 2y dy dt equals 2z dz dt. And our goal is to find the value of dz dt. So hopefully we have all of the information. We've got x, we've got dx dt, we've got y, and we've got dy dt, and we've got z. So all of our variables have assigned things, assigned values. Some students will notice that these are all multiplied by 2, so we can cancel the 2 so that we're dealing with smaller numbers. It's not required, but it does make it for smaller numbers. Then we go about substituting. X is 4, dx dt is negative 15, y is 3, dy dt is 10, z is 5, dz dt. So we get negative 60 plus 30 divided by 5 is dz dt. And this is negative 30 over 5. So negative 6 kilometers per hour is the rate of change at the time. So writing that in a nice sentence, when x equals 4 kilometers, the distance between the boats or ships, between the ships, is decreasing by 6 kilometers per hour. Now we have to be careful. We do not want to say decreasing by negative 6 because that's 2 negatives. So once you start to use the word decreasing, it accounts for the negativeness of that. Part B is worth 4 points. You get 1 point for the expression for distance. So +1 for understanding your Pythagorean theorem. Now there might be more ways to express this equation, but this is the way that I expressed it. Step 2 is 2 points where you differentiate with respect to time. So this is 2 points for differentiating with respect to time. And then step 4 is your evaluation, and so that's getting to this final state of what did it evaluate to? 6 kilometers per hour of decreasing distance. And that should intuitively make sense, at least because x and y are so close to each other. If this is moving faster than this, then probably the distance should be decreasing. Okay? There will come a time where eventually that distance is increasing, but for a while it's decreasing. So.
Little boy, why are you crying?
I can't find my parents.
All right, moving on to part C. Part C says, let theta be the angle shown in the figure. So in our diagram, we have theta being this angle, and this dimension, and this dimension. And they're asking us to find the rate of change of theta in radians per hour. So find d theta dt. And when are we doing that? It's the same snapshot moment. It's when x is 4, y is 3, and then we'll continue with z equaling 5. Given, and the rates that were given are the same, dx dt is equal to negative 15, and dy dt is equal to 10. And not that, I don't think we'll need it, but I'm going to go ahead and write down dz dt equals negative 6. It's kind of bad form to use found information to execute a problem, so I'm hesitant to want to use this piece of information because if I made a mistake with that number, that would cause a compounding error. So I'm going to try to do it with just the x's and y's. which means I need to come up with an equation that relates x's, y's, and thetas. And the equation that exists in this case would be tangent of theta is equal to, well, tangent is opposite over adjacent, so y over x. And that would be your relating equation for the variables. And I was able to get away without using a z in the equation, so that's to our benefit. Once we set up the relating equation, then we need to take the derivative with respect to time. The derivative of tangent of theta is secant squared of theta times d theta dt. And the derivative of the right is a quotient, so we'll need to do the quotient rule on this. The derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. So there's the quotient rule for that. Our goal was to find d theta dt, so we should check to see if we have all of these pieces of information. Can we find secant of theta? Well, we know the three sides of a triangle, so yes. dy dt we have here, x we have here, dx dt we have, and y we have, and x we have. Okay, we have all of the information that we need, so let's start evaluating this. Secant is the reciprocal of cosine. So cosine is 4/5, so secant would be 5/4. So secant squared would be 5/4 squared, d theta dt. dy dt is 10 times 4 minus negative 15 times 3 all over 4 squared. And then we'll start cleaning this up to solve for d theta dt. I'll apply the exponent, get 25/16 d theta dt equals 40 plus 45 would be 85 over 16. And then multiply the reciprocal to cancel that out, and we get 85/16 times 16/25, which is 85 over 25 radians per hour. And those are both multiples of 5, so you could reduce that if you wanted to. But in general, save yourself the time and the opportunity for error and don't do much simplifying. In fact, probably even simplifying this to 85/16 was maybe a bit excessive for the AP Calculus test, because I could have made a mistake there. So the point breakdown in Part C is worth 4 points, so you're going to get an expression for theta in terms of x and y. So that's this equation right here. 2 points for differentiating with respect to time. They dock 1 point for each error. So if you made a mistake in the quotient rule, like put a plus instead of a minus, that would be 1 error. If you forgot to include one of your chain rule applications, that would be 1 error. There's a note here that if the equation was set up with no trigonometry, you would get 0 out of 2 on this thing. So, and then finally your evaluation, which is what we were doing around here. Our evaluation is the final point.
Be sure to comment, like, subscribe, click that bell for notifications.
look for merch coming down the line. Throw some money in the Bitcoin wallet if you're feeling generous.